is that we will look at solvent quadratic function, okay? So remember last time we factor out the quadratic function, we end up with two products, like two expression in two parentheses. That's what we ended up with. But we have not do anything with that. We just stop right there, okay? So think about quadratic functions. Let's turn this on. So we're going to do an extra step. So we have this graph. So for example, we have this graph. Quadratic is parabola, right? It's like a U-shaped. It can be go up or down, depend on your graph. So it could be like this. Is this always at the y-axis? No. Sometimes we may have this graph. It can go like this, right? It's dependent on the graph that's given to you. So the point, when we factor it out, these two expressions will help you to find these 2 points on the graph. Okay, so when we factor out, we got that product, we're going to solve it. And what is the point of solving it? Because we want to know the x-intercept of that parabola. So it could be upside down, can be the U shape. So we want to find the point when the graph is touching the x-axis. Why do we care about that? Because we think about parabola is when we talked about we start at a certain point and we stop at a certain point. So like you throw in a basketball, or you think about when you make the jump, right? So those are the things when you launch something, or if you have this year when you have physics, one of the class, if you had it, Mr. Zhao could have something where you do experiments where you just shoot, I forgot what he did, something, the missile, and then it's just launched on the ground as well. So what we're going to do today, we're going to solve the function. We're going to solve to figure out the 2 point on the quadratic. So what we left off from last class, we have these two expressions. After we factor it out, this is what we have. So to solve it, you just set these two. I'm going to set this first expression equal to 0. Okay, so I would just set my each expression equal to 0, and that's how I solve it. So 3x minus 10 equals 0. I would do the same thing for my second expression. Once I factor it out, I just set that equals to 0. So this one would be x plus 5 equals to 0. So how do I solve it? Just set each parenthesis, each expression equal to 0, and then just solve the equation. So plus 10, 3x equal 10, divide by 3. You can simplify or you can leave it as fraction, or you want to get me the decimal, then you may. You can do 10 divided by 3, give you 3.33. Okay. You do the same thing for the second expression. You solve it by minus the 5 on both sides. So x would be negative 5. So what this was saying, if you just join, here is the link for you. Please click on the link, join Quadratic. I will use that to take attendance. So what this was saying for these two numbers is saying that if I graph this function, okay, the first x-intercept will be somewhere at the negative 5, and the second one is about 1, 2, 3, so it should be around here. So this is the graph. Something like that. So these are the 2 points that I'm looking at. This is the negative 5, and this is at 3.3. So the significance of those 2 points is tell you where the graph, the parabola, is touching the x-axis. So we are solving with another names that depend on the textbook. These are called the x-intercept, or sometimes we call solution. Okay. So that's the new part that we're going to focus on today. So we learn how to factor it out. We learn how to factor out quadratic functions. Once we factor it out, we're going to solve it I set each parenthesis, each expression inside the parenthesis equal to 0. Solve for the x. The x tell you where it's located, where's the graph touching the x-axis. Questions for me? Okay, I'm going to share the link again. If you didn't get it, please use that link. I'm using the roster on Quadratic to take attendance, so please join. All right, let's do another example. If I have to solve for this, again, I have two expressions. That's fine. I just set each of them equal to 0. So x plus 5, x plus 5 equals 0, x minus 5 equals 0. I'm doing the opposite to solve for the equations. So x equals negative 5 plus 5 plus 5 on both sides, so this would be 5. What does that mean? This means if I have the graph, it would touch at negative 5 and 5. That is my graph. These are the 2 points that I'm looking at. It's called the x-intercept, or we call solution. Sometimes we call the 0, or we call the x-intercept. Depend on textbook, depend on the test, depend on the program that you run into. Some may cause a 0, some may ask you to find the x-intercept, some may find the solution of the quadratic function. Okay, let me share the link again. If you just joined, there's a link. Please join. All right, I'm going to ask you to give it a try. Do the next one. I'm going to ask you to try this one. Go ahead and give it a try. Do it on Quadratic so I can see your work. Solve for this one. And if you can do a sketch of the graph to see where is that point in the graph, like I did earlier. If I have a graph, what does that point look like? So do a sketch of the graph if you can't. If not, that is okay, but I want you to go ahead and solve it. Try this one. Okay. So this one, what I would do, you see how I have two expressions? 3x minus 5, and the other one is x plus 5. I have two expressions. I will set each of them equal to 0. So I would do 3x minus 5 equals 0. Then I'm doing the same thing for my second expression, which is I have x plus 5 equals 0. Now I'm just solving the equation for each of them. So I would do plus 5. It doesn't matter which equation you solve for first. It's okay. The order is not important. 3x equal 5 divided by 3. So let's see. 5 divided by 3 give me 1.67. I round that up because it gives you 1.666. So I round it up to 1.67. Okay, doing the same thing for the second equation, minus 5. So that's negative 5. So these are the 0 or the x-intercept. And some of you, I think, what you want to see is a graph. So in here is somewhere negative 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. So this is negative 5. So that's this point right here. This was 1.67. So it's around here. So I can graph this function. Those are the 2 points that I'm looking at. Don't worry about the graph right now. We will spend the next lesson. We will take a look at the graph, but right now I'm kind of giving introductions of what it looks like. How I know it's open up because this function right here, there's a positive. If I have a negative in front, then I will concave down. We'll do more about that later. But for now, what I want you to think about the 2 points that you solve for are the 2 points on the x-axis. Okay? How do we feel about this? Good. Okay. All right. So what we're going to do is be nice if this is given to you. But unfortunately, that's not always the case. So for your practice today, you will have CUDA works. You're going to have two objectives. The first one is look like this. I already factor it out for you, and then you just set that equals to 0 and solve it. But the second objective is that we're going to go back and review. We need to factor it out. Then we solve it. So this one will take us some time, right? Remember how we factor it out? We have to look for A, B, and C. We have to set it up. We have to find the pair. So it takes a bit longer for the second objective. So we're going to combine what we learned from last week and we're going to solve. Okay, so everything that you learned along with the new thing today was going to solve for that x values. So in this case, we solve for n. Okay. So in here, I have 15, 51, and 42. I would want to look for the common, the GCF. So in here, the biggest number that I can see is all can be divided by, this one is a GCF problem. So I know I can divide the biggest number, the GCF, is 3. The number is really big. So when you run into a problem with big numbers, I would like you to think about what number can I divide so that my number can be a little bit smaller. So I will have 3. I will factor that out. So 15 divided by 3 give me 5m squared. 51 divided by 3 give me 17m. 42 divided by 3 give me 14. I want to pause for 1 second, let you copy this down, and then ask question like something bothering you, or it was like, is this okay? So give a few seconds to review what we covered. The GCF is the biggest number that you can divide by. And here I see the biggest number that I can divide by these 3 numbers is 3. So I use 3. When I divide by 3, I bring the 3 out here. Okay, so that way my expression is going to be a little bit smaller for me to deal with. Okay. All right, so the next step, we're going to factor this one out. So think about I have the values A, B, and C. This is A, is 5, B is 17, and C is 14. Remember this. If this is something that you forgot, you need to see me for help because we definitely need this. You need to know how to factor it out. So the top up here is A times C. The bottom is B. So A is 5, C is 14. So 5 times 14 give you 70. This one is 10. How do we feel about this so far? Do you remember this step? If not, write it down. Have it somewhere so you can go back and follow. This is not new. But it's okay. If you don't know it, just let me know. All right, we're going to need these 2 numbers. What are the 2 numbers that if I multiply give me 70, but if I add them give me 10? Can someone tell me? Why B is 10? I don't know. I just copied the wrong number. It's 17. So B is 17, yes. Sorry. Thank you, Zenobia. B is 17, not 10. I just copied it wrong. Okay, what are the 2 numbers if I multiply? Yes, 10 and 7. Perfect. 10 and 7. Good. So now I will factor it out. So I'm going to have these 2 parentheses. So m plus 10, m plus 7. But I'm not done. Remember, this called line divide, so I divide the a value, which is 5. When you write this, don't lose the 3. The 3 is there. You want to keep it. So we're going to simplify, which is 2. M plus 7 over 5. Because I cannot simplify that fraction. M plus 2. Remember, we do slide and divide. So I will bring the 5 in the front. Plus 2 equal 0. And now what you need to do is that you're going to solve for the m. When we solve for this one, even though there's a 3 out, we're not going to worry about the 3 because when you divide 3 on both sides, the number 3 is going to be disappear. So I will have m plus 2 equals 0. This is the new part. Remember we stopped right here before? Now we're going to solve for it. So we set each of the expression, this one and this one, each of them equal to 0. So 5m plus 2 equals 0. So this is minus 2. M is negative 2. So that's my first solution. Minus 2 on both sides. 5m equal negative 2. Divide by 5. M is negative 2 over 5. And we can leave it like that. So it's a lot of steps. It's a lot of work. However, the first few steps we already covered last week and on Monday. So it's not too bad. The only thing that you have to remember now is that I have to set each equation equal to 0, then solve it. Okay. If you need a moment to copy this down, do so. What I'm going to do is for the next slide, I would write down the steps. I'm going to write down the step for you, and I'm going to ask you to write it down somewhere that you can follow along, because as you notice, there's so many steps. Yes, if you do it in a piece of paper, that's fine. This is the notes for you because you have practice to do. So I want you to have notes when you do the summative, like you remember the step. There's so many steps, right? Okay. If you need a few more minutes to copy, let me know. Otherwise, I will change to the next slide. Okay. I'm going to skip this one. Okay, let's look at this one. Okay, so what I would do, I'm going to ask you if you can write down the steps to solve this one. Step number 1, I will look for GCF. Step number 1, I'm looking for the GCF. That is mean the biggest number that you can divide by. In here, they don't have the common divider, so there's no GCF, so I'm going to move forward. Step 2, I'm going to ask you to look for the value A, B, and C. A, B, and C. Okay, so we have A, B, and C, which is 7, negative 11, and 4. So you want to jot down the steps, do so, write somewhere. Step number 1, I'm looking for that GCF, the biggest number they all can divide. If I cannot find it, all right, let's look for A, B, and C. A is kind of hard to see, so let's A, B, and C. Okay. Still with me so far? If I lost you any step, then let me know. Step number 3, I'm going to use this diamond, or the X, or the diamond, whatever you want to call. The top is A times C, the bottom is B. So I'm going to fill out this number. So A is 7, C is 4, so if I multiply, give me 28. and this one is negative 11. So step number 3, I will work with that diamond, and I'm going to figure out what are these two numbers. So can someone tell me what are the two numbers that I should use for this? If I multiply them, give me 28, but if I add those two, give me negative 11. 7 and 4. However, it should be negative 7 and negative 4 because when I add them, that should give me negative 11. So we have negative 7 and negative 4. Good. I will show you how to use a graphing calculator to find it. If you have graphing calculator in a minute, I'll show you how to find that. Okay, that is step 3. Are we okay with step 3? Let me know. Yes, when you multiply the negative 7 and negative 4, the negative times negative, that's what is give you 28, yes. Okay, step 4, I will set up 2 parentheses. You're going to have k something. So you have that. That's the template that you want to use. If it's the x or that's the k, doesn't matter, depending on the letter that's given to you. So that's what you use. So I will plug it in. So this is minus 7, minus 4. Okay. Step 5, I will divide with the a values. So my a value is 7, so I'm divided by 7. Step 6, I'm going to simplify. So I can have k minus 1, k minus 4 over 7, which is 0. Okay. I'm going to pause. I'll give you a chance to copy it down. And then let me know. If anything bothering you, then just like, Ms. Wen, how you got that? Or I make a mistake, and you know that. I divide by a. Okay. So step 6, I just simplify that fraction. Step 7, some of you, if you talk to other students, called slide. We divide and then we slide the denominator. So let's bring it up here. So I will have k minus 1, 7k minus 4. That is the factor. So that's what we cover. So those are the 7 steps. Now what we have to do for today and the next couple of days, we're going to solve it. So we add a new step. So we're going to have step number 8. I set each of them equal to 0. 7k minus 4 equals 0. And then solve it. Okay. So step A, solve. Plus 1, so that's k equal 1. Minus 4. 7k, negative 4. So k is negative 4 over 7. So this is my solution. 8 steps. That's a lot of steps. Yes, totally agree. So if you notice, the summative, the last summative, I did not give you a lot of problems to do. Because I know it's a lot. So I'll give you a moment to copy it down. Alright, so what we're going to do is that if you have paper in front of you, if you jot down the step, that should help you to think about what do I do first. You may not do it correctly, but at least you remember the step. That would be very useful. Okay, so step number 1, I need to figure out if there is a GCF. GCF is the biggest number that I can divide by, right? So I have 8, 39, and 5. Between 8 and 5, I know I don't have a common divider, so there's none. So I don't have to worry about that. Step 2 is that I need to figure out my A, which is 8, B is 39, and C is -5. Let's write it somewhere here. Let's do it here. Step 2, A is 8, B is 39, C is -5. So that's step 2. Feel free to stop me at any step. Like, Miss Nguyen, what did you just do? Okay, because this one I'm just reviewing with all of you. The one who's ready to do the work, just go ahead and do it. So just stop me. Anywhere that you feel like you're missing or you're like, I'm lost, let me know. So step 3, I'm going to fill in this diamond, A times C and B. Okay. So A times C, which is 8 times -5 is -40. B is 39. I'm looking for these two numbers. The two numbers that if I multiply give me -40, but if I add them, give me 39. We spent a lot of time practice finding those numbers. So if you need help with that, again, if that's something you need to review, let me know. So I would have 40 and -1. That's step number 3. I think 40 times -1 give me -40, but if I take 40 plus -1, give me 39. Where do I get the -40? I multiply the top and multiply the A values, which is 8 times -5. Right here. I'm going to highlight it right here. Okay. To get that number, I'm taking the A values times the C values. Yes. Okay, step number 4, I would set 2 parentheses. That's what I would do. Okay. So my first parenthesis is going to be P because the letter is P. I'm using these two numbers right here. P plus 40, P minus 1. Step 5 divided by A. So I'm dividing 40 by the A value, which is 8. 8. Step 6, I need to simplify. Okay, so 40 divided by 8 give me 5. 1 divided by 8 is not going to give me a nice number, so I can just keep that. 1 over 8. Step 7 is called slide. So I slide the denominator over. So P plus 5, whoops. P plus 5. And then 8. 8P minus 1. So I slide it over right here. So I'm going to pause for 1 second. For those who need to take notes, you need to copy that down, do so. So let's finish this problem. Now I have these two expressions, P plus 5 and AP minus 1. I will set each of those equal to 0. So P plus 5 equals 0. AP minus 1 equals 0. If you solve this one, the first one is going to be -5. At 1 for the second equation, AP equal 1 divided by 8. P is 1 over 8. So that's my answer. So yes, I agree. It's a lot of steps, a lot of work, but you can do it. And I promise you on the summative, I won't give you a lot of problems, but I want you should be able to do those. It's important. Okay, so go ahead and copy this down.